one news, which is one of my favorite news or topics in general, which is about neuromorphic computing.
Ooh, you found one.
Neuromorphic computing. Explain that to me.
Okay, I can give some background. There is this traditional type of computing, which is based on what all computers and mobile phones is using. Is a von Neumann architecture. They have memory, they have CPUs, they have a clock, they have high frequency CPUs that do calculation, which is extremely energy
consuming.
Consuming.
And our brains are very energy efficient.
Exactly. So I think the brain is around like 12 watts. And if you take something to train ChatGPT, which is 1,000 of H100 or A100 GPUs, it's in the gigawatts scale. So it's just many orders of magnitude higher energy demands for the type of AI brains that we have today.
I see where you're going. Could we get a computer to work like our human brains? Yes. Much will be one.
Yes, and this is basically neuromorphic computing, and we had spoken a bit about this. Sam Altman from OpenAI had big investment in Rain AI, which is building neuromorphic computing systems. But now recently Intel released their big neuromorphic computing initiative. They've been working on it for many years, but now they had a big second release of the HALA Point. And in general, you can think of if you take the normal CPU, you have a clock and it's working at gigahertz frequency, and the brain is working at like kilohertz, a very, very slow frequency. And you have the brain and the neural cells that you have, which have the axons, the output point, and the dendrites coming into the other neurons and the synapse in between. But they are spiking, and they're all working independently, and they're working at low frequencies. And the thing is, it's not separating memory and compute. So each neuron has some kind of state in it. Whereas computers, they have transistors. They don't have any state. It's ones or zeros. And then memory. So when you have to train a model, you have to move data back and forth all the time, back and forth. And it consumes so much energy. And it's so high frequency. So if you instead can have the memory at the point where the computation is happening, which is what the neuron in the brain is doing, you would have significantly less energy consumption happening. This is basically neuromorphic computing. They call it like memristors, so like a memory and transistor combined become a memristor. So it has a state that is
How far have we come in developing that?
It's a lot of working lab prototypes. It's hard to make it work from an economical sense, but this is really where they are doing a lot of research right now. So it's basically still in the research stage, and the need, similar to like fusion, it's easy to get some kind of small prototypes working, but to make that work in an economical sense is still hard.